Hi friends, I am your Karthik Ravindra Kate and this is Kate Tutorials. In this video, I am going to talk about functional groups. Let us discuss one by one. First, I am going to consider the alkane. The general formula of alkane is CnH2n plus 2. That is, if there is one carbon, then we will get 4 hydrogen. And that the example is methane. Here one carbon and we have got 4 hydrogens here. And this comes under alkane. And the shape of this is tetrahedral. Next, let us see the structure of alkene. The structure of alkene is like this. That is, the second one is alkene, and it has got the general formula CnH2n. See, since I am using 2 carbons here, so C2H4, 2 into 2, 4. C2H4. This is the sigma bond and this is the pi bond, and there are 4 sigma bonds here, and the carbon is sp2 hybridized, and this is the structure of alkene. So this, since it is having 2 double bonds, this also we consider under functional group. So this double bond also comes under functional group, and we shall see some more functional group in the next classes. And the next one is alkyne. See, the general formula of alkyne is CnH2n minus 2. If there are 2 carbons, then we will get only 2 hydrogens. We can construct this alkyne using this alkene. What I am going to do is, just I am going to remove this 2 hydrogens and I am going to put one more bond. So this is the structure of alkene. It has got one sigma bond and 2 pi bonds. One pi bond, second pi bond, and only one sigma bond. And this is the formula C2H2. And since it is also having 2 pi bonds, this also we consider in functional group. This is the structure of alkene. So all this alkane and this alkyne, this is nothing but alkyne, are nothing but comes under hydrocarbons, because in this compounds only carbon and hydrogens are involved, so this comes under hydrocarbons. This is all about hydrocarbons. Let us see few more things like alcohols. Next we shall discuss about alcohol. Alcohol, they have got the functional group as OH. OH is the functional group. So I am going to consider the alcohol like CH3 CH2 OH. It is nothing but ethanol, or we will call it as ethane 1 all. So this is CH3 CH2 and OH. Here this color represent oxygen, and these are nothing but hydrogen, and black color is nothing but carbon. So this is nothing but alcohol. Let us see one more compound, that is ether. Ether having the general formula ROR, and I am going to consider here CH3O CH3. This is nothing but ether. CH3O CH3, right? Here 3 hydrogen and 1 oxygen. See, if you see these compounds, alcohol and ether, it is having 2 carbon, it is also having 2 carbons. It is having 1 oxygen, it is also having 1 oxygen. It is having 6 hydrogens, it is also having 6 hydrogens. So they have got same molecular formula, that is C2H6O, but the functional group are different. So this comes under functional group isomerism. This is nothing but isomers, because they are having same molecular formula, different functional groups. So this is functional isomerism, we will call it. We shall discuss it in my class, but these are the good example for functional isomerism. So these are the good example for functional isomerism. Next we shall discuss about carbolic acid. See, the general formula of carboxylic acid is RCOOH, that is R. Here this gray color ball represent R. R may be anything, alkyl, aryl. We can use methyl CH3 or C2H5, ethyl, propyl. Like aryl also we can use, that is C6H5. So R can be anything, and this represent carbon, and carbon is doubly bonded with oxygen, single bond and one more single bond, that is pi bond. So it is doubly bonded with oxygen, and here OH group is there. This is nothing but carbolic acid. And also From this we know that alcohol, this is alcohol CH3CH2OH. Alcohol react with carbolic acid and gives us sweet smelling liquid, that is esters, what we call it. So now we are going to discuss about esters. Esters are nothing but RCOOR dash. See here alcohol group is there and this is nothing but carbolic acid group. The OH of this carbolic acid will be removed and H of this alcohol will be removed and we will get esters. This is the structure of esters. Along with it the water molecule will be released. So along with it water molecule will be released. So alcohol when react with carbolic acid we are going to get esters, and the general formula of esters as I told R. See, this is R group, C double bond O R dash. R dash is nothing but here ethyl group. So RCOO ethyl group. These are nothing but esters. In esters we have got two oxygens, one doubly bonded and one with single bond. Along with alcohol when react with carbolic acid we get esters, along with water molecule is released, and this is H2O, two hydrogen and oxygen. And one thing you should remember, these carbolic acid and esters are also functional isomers. If we consider same number of carbon and hydrogen, instead of R, if I consider some set of carbon numbers and hydrogens, these also will be functional isomerism. About that we shall discuss in our class, but this is the structure of esters, RCOOR dash. So this is about carbolic acid and esters. And next we shall discuss about aldehydes. In aldehydes, see, the general formula of aldehydes are RCHO, that is RC double bond H. This is R. Here I have considered yellow group to be R, and this is carbon as usual black, double bond with oxygen, RCOH. These are nothing but aldehydes. Similarly we have got ketones, and the general formula of ketones is R C double bond O R, that is R C double bond O, double bond is there, and R, that is nothing but ketone. And also if instead of considering this R, if I consider like some compounds like set of carbon and hydrogen, these are also will be in functional isomerism, that is they will also have same molecular formula but functional group is changed. One is ketone and other one is aldehyde. We will get it if I consider same number of carbon and hydrogen. That thing we shall discuss in upcoming classes, that is in classes we shall discuss it. And the next one is ammonia. Ammonia means one H bonded to 3 hydrogens. See, this is ammonia structure, one N and bonded to 3 hydrogens. It has got lone pair of electron, but we are not going to consider that in this structure. It has got lone pair of electron here, because of which lone pair bond pair repulsion will be there. So bond angle will be reduced in ammonia compared to CH4. Because both are sp3 hybridized, we expect 109 degree 5 minute, 109.5 minute, but we are going to get here 107 degree. So this is the structure of ammonia. If I replace this one, that is if I replace this one H by other R group, let me consider one R group like this. If I replace this by one R group, I am going to get primary amine, that is nothing but this one, primary amine, RNH2. This is R, this is N and H2. So this is nothing but primary amine. If I replace one more hydrogen by another R group, let us see this, we are going to get secondary amine, and the structure of secondary amine is like this. See, this is nothing but secondary amine. We got R, one H and one nitrogen. Since two R groups are there, so it is secondary. And next we shall discuss about tertiary amine. Tertiary amine is nothing but we have got this hydrogen replacing by one more R group. So I got tertiary amine. This is the good example for tertiary amine. Since it has got one more lone pair of electron, I can again put one more R plus here. So it will be N NR4 plus, so it becomes salt of quaternary ammonia, salt of quaternary ammonia. So that will be the structure of ammonia. Next, let us discuss about one more compound, that is amide. In case of amide, what happens is, here carbon is there bonded to oxygen. Here oxygen is violet color, and this is R group, RCONH2, right? This is N and bonded to two hydrogens. It is the structure of amide, CrCONH2. And if I react this amide with the like this, if I replace this amide by this oxygen by nitrogen, I'm going to get amidine. That is nothing but amidine. This is the structure, RC double bond NH single bond NH2. See here NH2 I have got, and R is here, C double bond N. I need to get double bond N. Let us do that. So this is nitrogen. I am going to get it double bond with nitrogen. So this is double bond with nitrogen, and instead of this I want hydrogen, NH. So this is nothing but amidine, AMIDINE, amidine. That is C double bond NH. Here R group is there and NH2. This is nothing but amidine, right? This is nothing but amidine. And one more thing, that is the last, we are going to discuss about fatty acids. This is the nothing but fatty acids. In case of fatty acids, what happens is, see, this is the structure of fatty acid. Here carbons are there, and these transparent bonds are like white bonds are there, no, small. These represents hydrogen, CH3, CH2, 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 C double bond O. See here we have got double bond, C double bond O and OH. This is nothing but carbolic acid group. See, in room temperature also, these will be like continuous rotation. We can't isolate any of the conformation. These are called conformation isomers, because at room temperature the single bond will be continually rotating without breaking the bonds. Like this, they will be in continuous rotation. See, we can generate the same molecule by rotating, just simply by rotating we can generate it, right? Like this, they will be in continuous rotation, and we got the same. Like this, they will be in continuous rotation. This is saturated fatty acid, because all are bonded by sigma bond. We can have unsaturated compounds also. What we should do is just remove this bond and make it double bond. Simply by making it double bond, we are going to get unsaturated. That is, unsaturated means there should be two double bonds, right? So I am going to do that. So I am going to remove these hydrogens, and I am going to put that double bonds here. So this becomes unsaturated fatty acids. So this is the structure of unsaturated fatty acid. It has got one sigma bond, one pi bond. So there is two double bonds, and this is the structure of unsaturated fatty acid. And you can see here the bulkier group. See this, the bulkier group is like this, and hydrogen is here, and the other thing is hydrogen is opposite of this, and bulkier group is like this. That is, if both are, this is pi bond. If both these R groups, bulkier groups, are opposite to each other, then it becomes trans isomerism. To have it into cis, that is both R bulkier groups should be on same side, what we should do, just we should break this like this, and hydrogen comes here. The lower priority groups are downside and higher priority groups are upside. This becomes cis isomerism. So this is nothing but configurational isomerism. In case of configurational isomerism, we need to break the bonds, whereas conformation, there will be continuous rotation without breaking. That comes under conformation isomerism, whereas cis, trans, RS comes under configuration isomerism. Here we can see cis. Both molecular groups are on same side. So this is cis configurational isomerism, and lower priority hydrogens are one side, and these are unsaturated fatty acid. This is the end of this class. In next video we shall meet with some more models. Till then, take care and have a great day.